Welcome to This Explainer, where we are dissecting the hidden economics of AI agents. Look, we all love the idea of autonomous AI workers acting as these tireless extensions of our engineering teams. It sounds great, right? But today, we're going to pull back the curtain and reveal why allowing models to act as independent workers often results in incredibly unpredictable and, honestly, sometimes catastrophic costs. We're looking at the true hidden bill of agentic work, where seemingly simple tasks can silently drain your enterprise budgets. It's time to uncover the invisible mechanics that are driving these costs through the roof. To fix this, future enterprise AI requires a total shift in thinking. We need to move toward what's known as the energetic paradigm, or EP for short. This is absolutely crucial to enforcing strict operational and economic governance over intelligent agents. So let's dive into this and see how we can actually govern the autonomous future. Here is our roadmap for today. We've got 1. The hidden agent bill. 2. Human intuition versus agent cost. 3. The danger of token drift. 4. The EP governance layer. 5. The EP agent governance stack. And 6. The governed AI future. Let's jump right in. Section 1. The hidden agent bill. Exposing the true cost of agentic work. To really understand the true cost here, we have to grasp this concept called input context explosion. Think about it this way. An agent might generate a tiny patch of code, literally just a few lines of output. But completely invisible to you, it is paying over and over again to redigest repository contents, test logs, and its own historical messages. It's like paying someone to read an entire set of encyclopedias every single time they want to write one new sentence. There's a massive structural asymmetry here. The visible output is small, but the main energy sink is this repeated digestion of a massive, growing, hidden environment. You aren't just paying for the final answer. You're paying for the agent to constantly reorient itself. And this highlights a fundamental disconnect between standard, single-turn reasoning and true agentic coding. In simple tasks, your input and output are limited. The cost tracks directly with the visible behavior you see on your screen. But in agentic work, hidden input context completely dominates the cost driver. Tool results and accumulated history are being replayed across multiple rounds. The huge danger here is that users are budgeting based on the tiny, visible output they see, totally unaware of the massive internal tour the agent just took to produce it. Every API call, every file search, every failed test, it's all quietly racking up the bill. Moving to Section 2, Human Intuition versus Agent Cost. Let's look at why human difficulty metrics fail completely here. We naturally assume that a task that's simple for a human will be cheap for an AI, right? Well, actually, scratch that. It's totally backwards sometimes. Human difficulty measures cognitive burden, time, and debugging complexity. Agent costs, on the other hand, is driven entirely by search depth, tool routing, and context acquisition. For us, a simple syntax error takes maybe 5 seconds to fix. You spot it, you correct it. But if an agent lacks a precise map of relevance, it might endlessly search for the right file, pulling in thousands of irrelevant tokens, and cost a fortune in compute just to change a single comma. Conversely, a conceptually hard architectural problem might be remarkably cheap for the agent if the solution pattern is common and the right file is found instantly. The economic burden is absolutely not a simple mirror of human complexity. Section 3. Danger of token drift. The illusion of progress. Because cost and difficulty don't align, we run into a really critical malfunction known as reverse test time scaling. Normally, we assume giving an AI more time to think yields better results. But in agentic coding, beyond a certain point, giving a model more tokens to consume actually results in worse behavior and amplified disorder. Why does this happen? Well, an agent lacking strict stop rules might just get stuck in a local loop. It runs tests over and over, tweaking the wrong variables, without actually learning anything new. Energy stays inside the system, but without those strict stop rules, it does not convert into progress. It just tangles the code further and burns your budget. We really have to contrast productive search against what we call token drift. Productive search is purposeful. It reduces uncertainty, it tests specific hypotheses, it compresses old context, and crucially, it stops when the expected value of the next step falls. But token drift? In token drift, tokens act as wasted kinetic energy circulating inside the system. The agent expands its context infinitely, replays old state information, and just continues blindly until external limits, like a hard timeout or a max token error, eventually kill the run. All that energy is burned without improving the actual state of the code whatsoever. Section 4. The EP governance layer, a foundational control layer. To solve this hidden cost and token drift, we need a massive paradigm shift. We have to move away from passive observation and step into active economic design. The energetic paradigm, or EP, demands we stop treating token consumption as just some billing issue we look at the end of the month. Instead, it asks a really vital question. Was the cost converting into uncertainty reduction or only into more context? We have to start treating token spending as a live diagnostic signal. We need to understand exactly how energy flows through the agent's reasoning paths in real time. So how exactly do we do that? Well, EP enforces strict control by treating budgets not just as spending caps, but as pre-run boundary conditions tied directly to the task's value. It implements progress per token monitors and sets warning thresholds for low evidence quality. And crucially, it enforces rigorous context discipline. An EP-enhanced agent constantly separates active facts from retired noise, ensuring the model doesn't drown in its own history. It actively asks what must stay in active memory for the next valid step, and it prunes away the rest. This keeps the token flow lean and purposeful. And it goes further. EP treats every single tool call as a calculated conversion decision. An agent shouldn't just use a tool because it's available. It must route tools based on expected information gain. And when things go wrong, EP transforms failed runs from wasted billing events into highly structured diagnostic artifacts. It asks, was this a context failure, a tool routing failure, a stop rule failure? The next run should never restart from a place of ignorance. It should learn exactly which paths are dead and adjust its energy flow accordingly. Section 5, the EP Agent Governance Stack. Let's look at the mechanics of governed AI. Let's look at the architectural blueprint of how this operates in a live enterprise setting. This governance stack maps every ordinary agent function to a strict EP enhancement, ensuring continuous checks on problem progress before more tokens are consumed. Take planning, for instance. An ordinary agent just lists out sequential steps. An EP-enhanced agent shifts planning to early falsification, meaning it identifies the riskiest assumptions first to fail fast and cheaply. And look at evaluation. An ordinary agent checks if a patch works at the very end of the line. An EP-enhanced agent moves evaluation earlier, making it continuous, constantly checking if each additional token is still justified by the expected value of the task. It knows exactly when to escalate or when to abandon a low-value path entirely. Section 6, the governed AI future, scaling with discipline. What does this structural shift mean for the future of enterprise AI deployments? Under the energetic paradigm, the entire system is fundamentally reprogrammed. Tokens flow as governed, measurable energy. Context becomes a tightly managed reservoir rather than an overflowing bucket. Budget becomes a strict control boundary, and evaluation becomes continuous steering. By implementing this blueprint, the black box worker finally becomes an auditable, predictable production system. It transforms AI agents from uncontrolled, token-consuming black holes into highly governed entities that enterprises can actually trust and deploy at scale. Ultimately, AI models will only reach large-scale adoption when their effort and cost can be operationally governed. As the source materials so perfectly puts it, the winners in agentic AI will not only build stronger agents, they will build agents whose effort can be governed. So, I'll leave you with this final thought today. As we rapidly deploy these intelligent systems into our workflows, is your AI infrastructure ready for this level of economic discipline, or are you still just paying for the illusion of progress? Thank you so much for joining me for this explainer.